For the introduction session, this study used the car price data to analysis visual characteristics and understand factors related to car performance. In this study, we select two numeral variables, which are car weight and horsepower, and two category variables, which are fuel type and car body. Numerical variables are used to measure value that can be calculated, while categorical variables are used to classify data into different groups. We also examine data characteristics such as missing values and data distribution to ensure that the analysis is accurate and reliable.
We apply a simple random sampling to the car price dataset by selecting 35% of the total 205 observations. Using a random seed of 16665, we obtain a sample of 72 cars. The variable analyzed were cube rate, horsepower, fuel type, and car body. The sample shows an average cube weight of 2,489, an average of horsepower of 119, and is mainly composed of gas power vehicle and sedan body types.
First analysis aimed to compare the carb weight between diesel and gas gasoline group. The test results show a specificity scientific difference in carb weight between the two groups, with the t-value of a T203 is a 3.171 and p-value from 0.02. Variation in the diesel group has a significant higher mean weight of 2899 unit compared to the gas group, which is recording a mean of 2518 units. Next, we move to the analysis of horsepower based on an engine location. The result of the test return on not a number value. This occurs because rare engine group have a zero variation. The rare engine group contains only 3 samples, and all of them has exactly same horsepower value of 207. When there are no variation with a group, the test formula fails because it involves divided by zero, mean valid specific cannot be generated. This study provides strong evidence the fluid type play a significant role in direction weight with subtle effect size.
Hi, my name is Nurul Kamila binti Muhammad Zubri. My number matric A25A5273. My part is 3.0. So for 3.1 is in this session, we analyze two numerical variables, curb weight and horsepower, as well as we have two category variables, which is fuel type and car body. For curb weight, the average value is 2556 pounds with a minimum 1488 and a maximum of 4046. The standard deviation of 520 and 7 shows moderate variation in vehicle weight. For horsepowers, the mean is 0.4.1, ranging from 48 to 288, with a standard deviation of 39.5. This indicates that most cars fall within the mid-range of engine power. For fuel type, the majority of cars in the dataset use gas, accounting for 185 vehicles or about 90%, while only 20 cars use diesel. Finally, for car body, sedans are the most common type with 40 cars, followed by hatchbacks with 24, wagons with 6, and only a small number of convertibles and hardtop. For overall, this descriptive measure show that the data set is dominated by gas power sedan, weight, and horsepower values. For fuel type, the bar chart shows that gas power vehicle dominated the data set. Out of 205 cars, 185 use gas, while only 20 use diesel. This means more than 90% of the sample relies on gas, reflecting consumers' preference and industry trends that favor gas engines over diesel. For engine location, the bar chart demonstrates that almost all vehicles have their engines located at the front. Specifically, 202 cars are front engine, while only 3 cars are rear engine. This clearly shows that front design is the industry standard, with rear engines cars being rare exception. For curb weight, the histogram reveals that most vehicles fall between 2,000 and 3,000 pounds. The average curb weight is 2,556 pounds with a minimum of 1,488 and a maximum of 4,066. This indicates moderate variation in vehicle weight, with most cars clustered around the mid-range, balancing efficiency and performance. For horsepowers, the histograms illustrates that the majority of cars have horsepower values between 18 to 120. The average horsepower is 104 with a minimum of 48 and a maximum of 288. This suggests that most cars are good for regular use rather than high performance, as only a small number exceed 200 horsepower.
My name is Shalma Kisnila binti Muhammad Sufian Shah. My matrix number is 825A5354. So today I will present the significance level used in this study. The significance level used in this study is 0.05, which follows the standard practice commonly applied in business and social science research. This means that the study is conducted at a 95% confidence level. There is a 5% risk of committing a type 1 error, where a true null hypothesis may be incorrectly rejected. For example, this could happen when we conclude that there is a significant difference in car characteristic, even though there's no actual difference actually exists. The chosen significance level provide a balance between the risks of type 1 and type 2 error. Overall, this ensures that the statistic results are reliable, valid, and suitable for drawing meaningful conclusions.
My name Barkis binti Saharin. My number matric A25A5290. So first, I run a one-way ANOVA test. The purpose is to check if there's any significant difference in car weight, curb weight between diesel and petrol cars. Descriptive statistics. From the data, we have 20 diesel cars and 185 petrol cars. On average, diesel cars weigh around 2,018.99, while petrol cars are lighter at 2,518. If we look at the plot, clearly the bar for diesel is higher than petrol, so visually diesel cars do have higher curb weight. Assumption checks. Before that, I checked the assumption using Leibniz test for equal variance. The p-value is 0.052, which is more than 0.05. So the assumptions of equal variance is met. That means ANOVA results are valid. So then post hoc test, we use Tukey post hoc test confident. The mean difference is 380.3 and the p-value is 0.002. Since 0.002 is less than 0.05, we can conclude there is a significant difference. Diesel cars are significantly heavier than petrol cars. As an additional checks, I also ran the Kruskal-Walsh test. This is the non-parametric version of ANOVA. We use this when data is not normal and variance not equal. The result is test statistics 7.836, p-value 0.005. Since 0.005 is less than 5 than 0.05, it also shows a significant difference. So the Kruskal-Walsh result supports the ANOVA findings. Both tests agree that fuel type does affect curve weight.
For conclusion, this study analyzed a 30% sample of the cup price dataset consisting of 72 observations using simple random sampling with a random seed consisting 1,665. This method ensured that the sample fairly represented the original dataset. From the descriptive analysis, the average curb weight was 2,499.92 pounds and the average horsepower was 101.19 horsepower. Both variables showed a slight positive screw. Most vehicles in the sample used gas fuel with 90.28% and were sedan types 55.56%. For the inferential analysis, a significance level of 0.05 was used. Independent tests and one-way ANOVA were conducted to examine the effect of fuel type and body style on the vehicle weight and engine performance. Overall, the findings provide a better understanding of the car market dataset and the relationship between vehicle characteristics and car specification. That's all from me. Thank you.